today we'll be seeing the speed regulation of the motors by voltage control. It is having some demerits also. We'll be discussing that part. And what finally we need, we should be knowing a best method to start and control the speed of a motor. That is our requirement finally. In the first video or the part 1 video, we have seen the conventional starting and speed control methods, and we have seen some demerits on that. In this video, let us see what are the speed control methods of ceiling fan, and we will be discussing the demerits of this speed control also. And you will be getting some additional knowledge. The speed control of ceiling fan. The old conventional method was to use resistance regulator. You might have seen such a big box in the old method. And what this contain? One fan will be there and we are connecting the resistance regulator in series with the motor. And supply will be given. Naturally in India it is 230 volt. We are reducing the voltage here and the required voltage will be given to the motor. Why? If the voltage is reduced, the speed will be reduced. So this is the circuit. We may be having a particular voltage here and some voltage will be dropped here. Let it be V1 and the voltage it will be available to AC motor. Let it be V2. V1 plus V2 will be equal to V, and by reducing the V2 or by controlling the resistance, we can control the V2 available to the fan. And when the fan motor is having lesser voltage, it will be rotating at lesser speed. And what is the problem with this method? The size of the regulator itself is big because it is having a higher size resistance. Why? Because it is having higher heat. To contain the heat, the resistance size is high and obviously the regulator size itself is high. And because of the problems, what happened? This became obsolete. That is, it is not being presently used. Everywhere in the new wiring and all, you will be seeing only the new type of regulator. What is that? It is the electronic regulator like this. We will be seeing electronic regulator mounted to our switchboards, which is very small in size. And what is inside? There will be some power electronic component. What it is known as? It is known as triac. The triac, it is having 3 terminals. I am not going to the details of this item. There will be 3 terminals, 1 gate. The supply to the gate will be controlling the voltage. Like the AC will be like this originally, and by controlling the gate voltage, we will be able to control the waveform available to the load. Okay. Under some conditions, it can be increased and decreased. At some point of time, it can be reduced to very small voltage. So, electronic method also, we are controlling the average voltage to the load, that is fan. If the voltage available to the fan is less, its speed will be less. And because of the required voltage only given to the load, it will be having lesser heat loss. Because we are not wasting the voltage or wasting the power, we are just giving the required voltage to the ceiling fan. And the part of the waveform, it will be cut by the electronic circuit. So that is the reason it is having lesser heat. If it is producing lesser heat, the size will be less. And because of this advantage, we presently use this method everywhere. And to summarize, the resistance regulator and electronic speed control, both things are using voltage to the motor is being controlled. Okay, so the voltage to the motor is being controlled to control the speed. And what is the problem with that? Now, that is a demerit of or voltage control of speed with respect to this item. Let us see what is that. In induction motor, we know the equation or proportionality, torque proportional to square of the voltage. That is the important proportionality. The torque is proportional to the square of the voltage. And voltage is controlled for speed regulation, the torque will be reduced substantially. If you are reducing the voltage, what happens? The torque also will be reducing in a high manner. So that is the problem. If you are using resistance regulator or electronic speed control, we are controlling the voltage. The problem is it will reduce the torque. And the ceiling fan like loads will be requiring very small torque because it is cutting only air, and the voltage variation method will be okay for that because it is not requiring very high torque. You may be seeing also, you can control, or we can put a hand on the fan and start it. It will not rotate because it will not have higher torque to rotate when we are blocking it by hand. But do you think you can stop a bigger motor for 5 HP by your hand? Can you hold the shaft of motor by hand? No, because it will be having very high torque. So it is having high torque, we cannot stop by hand. That is, some capacity, high capacity motors, it is having higher torque, we cannot use voltage control method because the motor need higher torque. When we are reducing the voltage, torque will be less. We cannot run the load by this motor. So the higher capacity motors cannot be used with voltage control method for speed variation. So in the part 1 video, we have discussed what conventional start and speed control methods and its disadvantages. And in this video, up to now, we have discussed the voltage variation, that is resistance regulation or electronic speed control, and these two methods are not suitable for higher capacity motors because this method will reduce its torque. Now, to retain the good torque, what we'll be able to do? There is a new technology that is known as variable frequency drives. It is known as AC drives too. We'll be studying that in detail. And in the next video, we will be discussing the speed control method of motors, and it is without losing the torque. How we will be able to control the speed without losing the torque. That will be our point of discussion in the next video. And I have not forgot this to you. Now, in the new technology, something known as BLDC, brushless DC ceiling fan, is widely available, and it is energy efficient. That is, it will be using very small power. Normally a ceiling fan takes 70 watts of power, but this type of fans may be taking around 30 to 35 watts. Sounds good, is it? And it is operating even in wide voltage range, maybe 90 to 230 it will be operating. It will not reduce the speed. So this is the new technology item, and this is almost similar to our AC drives. We'll be separately discussing the operation of BLDC fan in a separate video, and why it is used, because nowadays the manufacturers or the customers are more looking for better efficiency, because you will be using home UPS in the office or home or industry, everywhere you are using the efficiency in usage. It is important. You may be seen the star rating of machines to save the power on energy, and even we are using solar power. So the energy efficient method, it will be saving your power, and that is the reason BLDC ceiling fans are used. And BLDC ceiling fans, it is similar to our technology in AC drives.